Welcome to another podcast. In this episode, we're going to be taking a look at a couple of examples for chain rules. So these are just sort of extra examples on top of the chain rule video which you've watched previously. Let me just remind you of what the chain rule says. It says that if you have a function f of x, then the derivative of that function df dx is equivalent to the derivative of the function with respect to sort of a substitution variable, u, so df du times du dx. So the function u is this sort of intermediate variable which represents the inside function. So u of x is the quote-unquote inside function or the composition function for the problem. So for this particular example, we're going to, for both these examples, we're going to apply this rule in this form because I want you to get used to applying it using a substitution rather than just trying to do it all in your head. Once you get a little bit better at it, then you can do all this in your head once it becomes sort of second nature to you. So we're going to start with df dx is the derivative with respect to x of f, and the function f here is 5x plus 8 cubed. Now, in order to simplify this function into something we recognize, I'm going to let u be 5x plus 8, so that I'm really just looking at the derivative with respect to x of the function u cubed. Now, in doing that, I've replaced this function, which is the function f of x, with this function, which is the function f of u. So I need to find df du, and that's what this is here, df du, times, the chain rule says, if I do that, if I make that substitution, then finding the derivative also involves finding the derivative of my substitution. So it's times du dx. So if I'm going to do this out completely, I need to also figure out what u prime is here. So if u is 5x plus 8, then u prime is 5. And so carrying this over, the derivative, this should be the derivative with respect to u here, because this is a function of u. So the derivative with respect to u of u cubed times the derivative of u with respect to x, but the derivative of u with respect to x is just 5. So this is the chain rule part. The chain rule is the entire rule, but we think of chain rule as the 5 is what we have to multiply by here. So now I just take the derivative of the outside function, which is what this part is. I think of the outside function as being the cubing function, u cubed, and I think of the inside function as being the substitution, u equal 5x plus 8. So that once I've finished doing this, the derivative of u cubed is 3u squared times 5, which is 15u squared. And then substituting back in for u to get back to the original variable x, I just substitute in 15 times 5x plus 8 is for u. And so this is 15 times 5x plus 8 squared. So this is the derivative via chain rule. Now, like I said, once you get better at this, a lot of you are just going to say, okay, well, I've got 5x plus 8 cubed. So normally when I cube something, I do power rule, which is 3 times that thing to 1 less power. But because this isn't just x, I have to multiply by the derivative of that thing. And so the derivative of that thing is 5x plus 8, which is equal to 5. So this is 5 times 3, gives the same answer. So I think most of you are going to eventually do it this way. So if you're thinking in your head, this is probably the way that you would do it, but for those of you that are a little bit unsure of yourselves, you can always make this substitution, and even for those of you that are sure of yourselves, it's probably a good idea to get in the habit of making that substitution u for the inside function just until you get a little bit better at this. So let's look at this second problem now, and I'm going to apply the same sort of analysis. For this second problem, I have to do a little bit of work first because I've got a function here and a function here which are multiplied. So product rule applies. So this problem is going to have both a product rule aspect as well as a chain rule aspect. And so the chain rule part of the problem is going to come from the fact that this power is not just an x. And so we don't know how to deal with that power very well without applying chain rule. Because we know what the derivative is for e to the x, but if it's not just x, instead it's 5 minus 3x squared, then we have to apply chain rule at that point. So remember what product rule says. It says if you have a function f times a function g and you take the derivative, then it's f prime g plus f g prime. So that's what we're going to do here. So I'm going to start off by taking, in order to find the derivative, I'm going to start off by taking the derivative of the first function times, so f prime, times the second function plus the first function times the derivative of the second function. Okay? In doing that, what is the derivative with respect to x of x squared? Do I need chain rule yet? No, that's just normal power rule. The derivative of x squared is 2x. So far, so good. I don't need to apply chain rule yet. But when I come to this piece right here, I'm having to take the derivative of something other than just e to the x. And so in doing so, I'm going to have to make a substitution. My substitution here is going to be u is 5 minus 3x squared, so that the derivative of u is negative 6x. If I make that substitution, then this becomes, by chain rule, this becomes the derivative with respect to u of e to the u times the derivative of u with respect to x via chain rule. And so, writing down the rest of what we have here, the derivative with respect to u of e to the u, so this is the outer function derivative. The outer function derivative here is e to the u. And the inner function derivative du dx is negative 6x. So putting everything in place, we've got 2x e to the 5 minus 3x squared plus x squared times, in fact, let me go ahead and combine these. We've got an x squared here and a negative 6x here, so that's negative 6x cubed times e to the u, where u is 5 minus 3x squared. So this is e to the 5 minus 3x squared. And so one last little simplifying step, I'm just going to factor out that exponential and give my final answer in this form. So you can see here that chain rule applies anytime we have to take a derivative. And if you remember product rule and quotient rule, both of those rules had derivatives as a part of the formulas. So chain rule is sort of an ever-lurking presence anytime you're taking a derivative. You've got to be aware of it. So it can show up in product rule, it can show up in quotient rule, it's going to show up all throughout the rest of the semester. And in many ways, chain rule is one of the more important techniques we teach in this course. And so it's well worth your time to make sure you understand kind of what's going on here. All right, thank you for watching.